What's going on, everybody? So I'm back doing an explanation video. In my system, the conjugated coil I threw together, it's kind of rough right now. I didn't add some parts to it. I didn't add the boosting LC circuit, which is the inductor and the cap to the coil, the primary. I didn't do that yet. The secondary is 4 inches long, wound on a 1-inch diameter PVC pipe. So the primary, 1 inch long, secondary, 4-inch long. I left a 1-inch space on the pipe to avoid interference and to try and create a cause and delay effect with the power. And I did not add the cap or the one-way diode yet. I just straight connected the wire from L2 to L3. And then this coil, L3, is 1 inch long. You can see I wrote it all down here. L1, 1 inch long, L2, 4 inch long, L3, 1 inch. And I'm still not sure on the perfect L4 length, and L4 is a dielectric antenna, not a coil. L4 would be shorted out. The ends would be shorted out, and you connect your lead to the center. It's a dielectric antenna. You're trying to tune into the earth and accumulate more of a charge in the system at a high voltage, high frequency at the top. And you don't want any arc outs occurring on your device. That's key. And I experimented with a big titanium ball. I'll show that soon. Here's a bunch of schematics, theory how it works. The coil's inducting up to the sun, matching the frequency and trying to gain more power. It also wirelessly inducts into the earth, and when it transmits the power, it's theorized it makes a standing wave, and that's why you get your power between two separate ground points, and you can light a small bulb or a LED. Here's just a bunch of math I was doing for correct transistor values to avoid blowing them up. That's not really that important with what I'm going to tell you now. So this is how my diode chain was configured. You have to have one N4148 diodes. It will not work with any other diode, to my knowledge. Not at these efficient power levels. Like, you need these diodes. And the center of the chain gets grounded. You can see my chain right here. That's how advanced it is. Just is taped to a PVC pipe, and the ground connection is at the back here, the center. And that's where the extra power comes from. And this baby will put out 1 or 2 kVE at anywhere from 30 to 60 milliamps, depending on how I bring this thing near the coil. So I bring this diode pickup near my transmitter coil, and I have a ground connection going to the back center of the chain. Exactly like this. You can make your chain as long as you want, and the moment you ground it to earth ground in the center, you get like some kind of energy pumping effect, and you get massive amounts of power out of it. Like scary amounts. Enough that it'll shock the shit out of your fingers. That's how the chain looks. It's literally just an up-down pattern all the way around. Up, down, up, down, up, down. Nothing crazy. Literally up, down, up, down. And the outputs just have a capacitor to store a little bit more of a charge. Up, down, all the way around. It's literally that. And you ground the center. And if you want to add more to it, you just add, you do it evenly. You add another diode here, and you balance it, add another diode here. So you extend it kind of like how nature draws a line, like from the center outward. So if you were to extend this, you go 1 diode here on the left, 1 on the right, 1 left, 1 right, and that way your ground point stays centered. So the transmitter, you can optionally ground the bottom of the secondary. You don't have to. I discovered that when the device is within 10 feet of the ground, it will wirelessly induct into the ground, so you don't have to ground it for the effects to occur. You don't have to ground the transmitter at all, but if you ground, like I said, if you ground your pickup diode system in the center, you get massive amounts of power, because the pumping effect still occurs. This was my modified circuit that I was using. That's my exact circuit. The resistor is one I got on there now is a 18K and that will vary depending on the coil you use. If you make just a simple 4-inch long coil on a 1-inch diameter PVC pipe with a 1-inch long primary that's 8 gauge, your resistor is going to be 22K. That won't fail you. Like, it'll work all the time, guaranteed. So your resistor value is always going to vary depending on your coil parameters, and you got to do some math involved, or you could do online calculators. But the fact that I switched to such a big transistor, the 2SC3264, it can handle, like, you can be pretty sloppy with your base resistor and get away with it. You'll just generate more heat in the circuit and be less efficient. So it's a pretty big chip, the 2SC3264, that runs it. And here's another schematic, a little bit cleaner. Feel free to pause the video on it. That's my exact schematic, minus the dielectric antenna top load. You can experiment with different designs, it's not that important. So yeah, that's the pickup chain. And I'll show you the effects of the transmitter. Here's how the transmitter looks. It sits on a heat sink. So L1, L2, the 1-inch space, L3, and this is the top load, the dielectric antenna. See how it's shorted? And this is all removable. You can just take everything off. See? Everything's removable from this thing. And it's all hollow. Everything's hollow and removable for modularity and to make things easier. And I just connect the L3 to this right here, and it starts to work. This creates your dielectricity. So electricity comes from the dielectric realm, and you want a big antenna to create that. And this was the sphere I was experimenting with. It's not quite the correct dimensions, but it still works. It's a rainbow titanium sphere. I believe it's 8 inches in diameter. I probably need one at 4 inches or 6 for my system to be perfect. And I'm going to be getting one of those soon. I'll also show that I'm basing all my work off of all these electrical documents. So, like, I'm not just talking out of my ass, I'm basing my work off of all these electrical documents. Like, we got, see, dielectricity, capacitance, where energy comes from. I've read almost all these articles. Like, I'm not bullshitting anyone, this is my hobby to figure all this stuff out. The giants of electrical engineering theory, ancient electrical engineering theory, say you can extract infinite amounts of power from the dielectric realm. Yeah, Eric Dollard is a god with electricity. We got this one, which helped a lot. Theory of Wireless Power by Eric Dollard. All free PDFs you can download. And my favorite one is Condensed Intro to Tesla Transformers. This helped a lot. And it'll tell you right here that unknown phenomena and overunity occur with a grounded Tesla coil, a real grounded Tesla coil. I just tried to make one that's solid state and silent. And any Tesla coil you see online shooting massive sparks is not a real Tesla coil. That's not how they work. Modern academia completely twisted it like everything they usually do and didn't make it correct at all. I mean, it literally tells you in the original papers how to build a real Tesla coil. And anyway, I'll go back to what I was doing. All this is free PDF you can download. You see they talk about the dielectric antenna, the L1, L2, L3, and yeah, back to what I was doing. So here it is, the chip is on a heatsink. Really simple circuit. Didn't even add the capacitors or the diodes. Didn't even add the boosting LC circuit to it yet, which will probably improve it even more. The resistor goes usually on the bottom of the coil. They both have to be wound in the same direction. I'll actually get a measuring tape and show you the dimensions just in case no one believes me for some reason. So, here's an idea of how big it is. L1, 1 inch. L2, 4 inch. Then a 1 inch space. L3, 1 inch. Dielectric antenna, 2 inches. So, I'll turn this thing on and show you the cool effects. I'll make sure my ground lead is right here. It's literally just a ground lead. I ripped out the other wires except for the ground connection. I'll have this come up and I'll have it set up so it doesn't fall. I'm probably going to switch out this wire because this wire is too thick and it always fights me. So, here's my diode chain. I'll connect it to my voltmeter. So I'll hook up my voltmeter first to my diode chain, the output. And I'll show you the output without it grounded versus with it grounded. So, I just don't like how all this is fighting me. Hold on. So here's the ground. I'll get these LEDs out of the way. These were rectifiers I was experimenting with. Little LED pickup, Avramenko plug with my own diode configuration. You can see that. Up, down, up, down, up, down. And if I wanted, I could ground the center and get more power. So here's the diode pickup chain going to my meter. There's nothing under my desk. Nothing secret in my room. A lot of trolls tell me I'm faking stuff, but sorry to tell you, I'm not faking anything. This is real research, and if it startles you, so be it. So, as you can see, we're getting a voltage out of this guy because he acts like a power detector for just any ambient RF. So I'll turn my system on. I can run it from anywhere from 5 watts to 80 watts. 80 watts, it gets really hot, and as I'm turning it up, usually run at about 25 volts. So, as I'm turning it up, you see this lights wirelessly. The range is pretty decent too. And notice how I move this far away, right? It's out of range. And the moment I add the ground connection to a coil, it'll light up. Like, watch this. The moment I ground it, it lights up. Look at that. And I can move that very far away. I'll even demonstrate that down here. I'll even demonstrate that way down here and it will light up. So I connect to earth ground from my heater, right there, goes to my heater, and watch this. It still lights up. Look at that. Should light up, there we go. So that was another discovery I made. Pretty crazy. Oh, and I think I just broke this coil. Yeah, this coil's been abused and it's now broken, see? That sucks. I've had this since the beginning. I broke it when I brought it up, when I just brought it up here. And the meter's freaking out because the system's on. See what you get. Yeah, I need like an RF meter to read this properly. So yeah, we're getting 99 volts with an ungrounded diode chain. And if I bring this close to the coil, it'll put even more power. Like, see this? And let's see if we can connect the bulb to this directly. You gotta forgive me, I'm filming things with one hand and everything is fighting me. So I'll connect this to my most sensitive LED bulb, which is this one. So I'll connect this to my most sensitive LED bulb, the pickup chain. And you can see it's completely wireless and removable. Like, I can just walk away with it. And I bring the chain near the coil. It lights up very intensely from that special diode. Like, look how intense that will get. And that's not even the over unity part yet. The over unity part occurs once I ground it. So, I'll grab a green wire, which represents ground. Here's my ground connection. Watch what happens when I ground the back center of the diodes. I bet the bulb will light. Might have to move it just a little closer. There we go. The range gets much better too. So not grounded, grounded. No ground, ground. See that? And when you do this, there'll be no change on power draw, 20 watts. And I can bring this super duper close, and look how bright that'll get. You can literally see what it is. And to make this thing even more perfect, I'm going to wind it on acrylic pipe, not PVC. Because acrylic won't absorb my dielectric field like PVC does. I'll get even better efficiencies winding this thing on acrylic. So I'll connect this 40 watt LED bulb to it. See the package right here? I'm sorry, it's a 5 watt LED that looks like a 40 watt. So I'll connect this really bright LED to it. And we'll kick on to full power without changing my input draw. I just gotta move the pickup close to it. And there we go. Notice my power consumption doesn't change. And I don't even have things perfectly tuned yet. Like, the best ideal setup would probably be to get this thing in the center. Like, look how bright that gets when it's in the center. Like, damn, man. See that? Very crazy. And it can even run incandescents. So I'll show you the output and current on this thing. So, hold on, it came off. So here's our current output. Oh, I didn't change it to milliamps. There we go. And this fucking thing keeps coming off. It's so annoying. So here we go. And if you get this perfect without letting it arc out, we get like 30 to 60 milliamps. There we go. You can experiment with the orientation too. And there's no change on source. The only time it fluctuates is when it arcs out, which is occurring up here a little bit. So, and then again, I'll connect the load. Very bright. Oh yeah, very bright. And I'll show you the system again. how good it is with fluorescent tubes. But yeah, the ball top load is slightly too big. That's the range with fluorescents. About 5 feet. And I'll get back to showing you how the system was constructed again. So here's how it all looks. And it literally just sits on a heatsink. Everything's removable and modular now. Bottom of the secondary connects down here. You can kind of see that. Everything's removable. You can see through it. There's nothing funny going on. There's nothing under the heatsink. It's just a heatsink. And yeah, that about does it for this video. I explained everything, the theory, how it works. Here's the diagrams again. Feel free to pause it anywhere. We got that diagram, that diagram. So, these are the most important. The optional ground from the transmitter. As long as it's within 10 feet of the earth, your transmitter will wirelessly induct into the ground and you get these effects. You have to use 1N4148 diodes or it will not work. And yeah, you make that diode chain, ground the center, you're good to go. There's my circuit. I like to draw my transistors like that because the other way confused me a bit. I mean, that's the right way to draw it. That's my real circuit. I mean, just pay attention to the circuit. It kind of ignore the component list except for that. So, yeah, things are getting fun. Stay tuned, and a lot more to come.